Right, so this is a second review class. Now, remember, you're given the homework, right? 60 problems. I'm not sure how you did it. That would be 60 problems. The way you do the homework is you finish all of them by yourself. And maybe some of them you cannot do, some of them you make mistakes. You use answer key, check it. And redo the problems, you make mistakes. And trying to spend 3 more minutes on those problems, you cannot do it. And finally, you check and give the grade, percentage grade for yourself. Okay, and I hope everybody get at least 85%. Okay. So today, I'm going to begin with the geometry. Okay, that's a review, right? The first one I want to talk about is a cube. Okay, cube. A cube is a rectangular prism. Okay. What we should know? Well, that's cube, right? All the sides are equal. So how many faces it is? 6 faces. Then each face has area, a square. So 6. So 6 times a square. That's a total. That is a total surface area. And then volume is going to be a cube, right? So that's clear. Right? And then we are given some problems. Sometimes we are told the surface area, we're trying to find the volume. Sometimes we are told, we are given the volume, trying to find the surface area. Another one is the diagonal. Okay, the length of the diagonal. The length of the diagonal is going to be square 3 of the side. Okay, the reason is, okay, this is not definition that we derive it. The reason is, and d square equals a square plus a square plus a square. Okay, that's a special Pythagorean theory. Okay, so given that, you can get that result. All right, so the question here is that if, okay, if the surface area of a cube, okay, is 600, for example, right? Okay, square units. Okay, 600 square units. Let's call it square centimeters. So, what is the volume, right? So to do that, you write on the formula, and you know the surface area is 6a square. Then that's a 600. Okay, so then from there you find the edge length. Okay, now sometimes you can even bypass it, right? And you get 100. The square is get 100, so a is going to be 10. Then you write in the volume formula, then you get 10 cubed. That's 1,000 cubic centimeters. Okay, that's how do we solve the problem. Okay. Now, sometimes if you know the length of the diagonal and you want to figure out the surface area. Okay, so it's uniquely determined. All right. So that's just a relationship among the cubes, among the quantities about the cubes. My next term is a pyramid. Okay. Pyramid. What's the definition of pyramid? Okay. A pyramid more precise. Sorry. A pyramid more precise. Sometimes we have to say. Usually, a pyramid means the pyramid looks like the pyramid in Egypt. It's a square based. So sometimes we have to say square based pyramid. Sometimes the base is a triangle, then we don't call it even pyramid in some. Okay. A pyramid, yeah, take a look at a pyramid. Okay. Because this is a pyramid. Okay. And this side is A, this side A. Okay. And this is going to be H. The height is going to be H. Now, what we should know about the pyramid? Okay. Just three-dimensional. Okay. Well, this is a cone-like solid. So the volume, there's a formula. So it's going to be 1/3 of the base area times height. Okay. Now we're also interested in the triangle on the side. Okay. Suppose suppose the triangles are all isosceles triangle. Okay. Then how they're related? If this side is B and this side is B. Okay. So this is an isosceles triangle. Okay. It's not easy. Okay. Because B, A, H are already dead. Okay, I want to apply the Pythagorean theory to solve the problem. So what's the relationship between B, A, and H? Okay. Yeah, this is difficult one. Now we are in the advanced math class. We're going to spend more time to study that. Okay. You can find out if this kind called X, right? X squared plus H squared equals B squared, right? That's the right triangle, vertically put that. Okay. Then how do you find the X? Well, look at this square base. Okay, what is X? This is A, this is X, this is X, right? This is the right triangle. So X squared plus X squared equals A squared. Got it? Then you can find the relationship between them, right? So half of X squared is half of A. Half of A squared plus H squared is going to be B squared. So that's the relationship between those three quantities. So if you measure, you look at that, oh, here's a pyramid, right? And each face is a isosceles triangle. I can measure the base, I can measure the side edge. Can you tell immediately the height of the pyramid? The answer is yes. The height of pyramid is going to be B squared minus half of A squared, and then you take the square root. So sometimes as an engineer, you have to figure out the formula. So then you see next time if you go to Egypt, if you see in the pyramid, you can figure out the base, right? The length is a square base, and then also the edge from one point, bottom part to the top. If you can measure that, then you can tell the height. You see, otherwise it's very difficult to measure the height directly. Okay, so this is that's why we need the geometry, right? And the Egyptians are actually very good in geometry. Okay, I visited one of the Egypt. I have visited at least 6 pyramids. It's a long time ago. Okay, it's very hot. Even November, I went to that. It's very hot, just like a summertime. All right, so now I'm going to look at another problem. All right. So the problem is here is this you did already, maybe. Okay, so right pyramid, it's still called pyramid, but there was an equilateral triangular base. Okay, equal triangle base. Okay, it's equal triangle base. Okay, this is equal triangle. So you can mark it A and A and A. Okay, right? And the area of one face of right pyramid was equal triangular base is 75 square meters. If the height is 30 meters, what is going to be the length of the side of the base? Okay, here's the point. Okay, right? Now look at this, right? Right, what do you mean right pyramid? Okay, right pyramid is from any angles you can look at, it's also same. Okay, so it's not like all the three triangles on the side are the same triangles. So they are source triangles. So we know the one face. Okay, so all the faces are same. Okay, so if we know the height, if we know the slant height of is what do you mean slant height? Okay. Okay, so actually it's just about triangle. Okay, so if you have a triangle, right? Okay, you have an equal rate. Okay, if this is a height h, what's the relationship between a and h? Okay, what is the relationship between a and h? So this is just two-dimensional geometry problem. So equal triangle, that's a 60 degree here and a 30 degree here, right? That's a special triangle. So you can find the relationship. So this is a right triangle, right? So this side is A, this side is half of A, and this is H, right? And what's the relationship between them? So H square plus half of A square equals A square. You're applying the Pythagorean theory. Okay. And then H square is going to be A square minus half of A square. And after simplifying, it's going to be 3/4 A square. Okay. Then this one is going to be H is going to be square 3/2A. Why? Because the square root of 3/4A square is going to square 3/4 and square A square, and each of them, okay, you will get this. Okay. So this is how do you get it? So you get the height of the equal triangle expressed. Now, can you find the area of the equal triangle? So area of the equal triangle, okay, is going to be the half of the base times height. Then the base, the height you already get. Okay. Finally, if you simplify it, you get that. So I would like to memorize this formula. That's so special when you have an equal triangle. The area A is always equal to 3/4. That will help you to solve the problem, speed up the problem. Okay. Okay. So now if you are given the area, if for this equal triangle, if the area is going to be 75 square, right, square meters, for example, okay, then you actually can get the edge length. Okay, you can get the edge length. Okay, for the equal triangle. Okay, now then this is going to be that would be, let me just give you, I have to modify the problem, okay? Otherwise, you will get a very strange number, okay? I'm not going to use, I'm going to use a different numbers here, okay? So let me put, okay, let's say 9 square root of 3, how about that, okay? So I get that, and then you want to find the edge length, okay? So to do that, you just solve this equation, okay? So square root of 3 over 4a squared. Now the reason I want to give you square root of 3 here, because otherwise I get square root of square root of 3, but it's so kind of strange number. So here you get a squared 4 times 9. So a is going to be 6, okay? So that's a 6 meter, okay, 6 meter. Now, if here's an isosceles triangle, okay, this is a B, this is a B, this is A, okay, and this is a H, okay, this is H, okay. So the area formula is half of A times H, right? Then can you express the area in terms of A and B? Well, again, that's a little bit more general than that, right? Then you can apply the Pythagorean theory to find the H, right? We already did that, right? This H, there's half of A. So by the Pythagorean theory, H is going to be square root of B squared minus half of A squared. Now, why this is true? Because H squared plus half of A squared equals B squared. Then you move half of A squared to the right hand side and solve for H, okay? So therefore, area is going to be half of A. That's more complicated than what you thought, right? Okay. Anyway, those could be the yeah. So you can derive the formula by yourself. Back with that, okay? So if you have an isosceles triangle, if you know if you know the base, if you know the edge length or the edge length, you can get the formula. Now for the problem, if you if you just know the height, you know the area, then you can easily find the base. Okay. So here's a question for an isosceles triangle. If this if H is going to be, let's say 75 centimeters, right? If area, you know that this is a so this is a 30. Okay, just say if the area is 75 square centimeters, right? Then you can find the base. Okay, that's just directly because this is a easy formula. That's the easiest formula. Okay, so then from here, you can get A, because right, twice capital A divided by H. Okay, right, you solve for A. So 2 A is 75 and then multiply by 30. Okay, and then and it's 150 divided by 30 is going to be 100 over 30 is 5. Okay. Okay. So the base is high. Now I have to go back to well, let's look at the problem here. It's all related. I have an equilateral triangle. Okay, if you want to solve 3D problem, probably also have to understand this. I'm going to draw the lines. Right? Okay. I'm going to draw the lines. So I would like to know this length. Okay. They're all equal, right? Yeah. Can you express x in terms of a? So, whoa, that's tough, right? So how can they? But there are a couple ways to do. Okay, if you recognize this is a right triangle, not only that, if you know this is a 30-degree, because this divides the angle equally, right? Right, equal right triangle, each angle at each point is going to be 60 degrees divided by 2, 30 degrees. And here's half of A. That is X, right? Now for the special triangles, I keep saying that these two sides are related, X and the 2X. As long as you're given this, then you can solve the problem. Because x squared plus half of a squared by the Pythagorean theory is given this, right? Then how? Well, this side is a square, half, and then the other side is 3 squared, 4x squared minus x squared, which is 3x squared. So you can solve for x squared. Okay, and finally, x is given square of 1 over 3, and a of x squared. No x squared. So that's what you get. Okay. Yeah, you can rationalize it. The first term is going to be square root 3 over 3, then half of a. So my answer is square root 3 over 6 times a. So that's the relationship between x and a. Okay. But there are other ways to get it. Okay. There's other way to get it. If we have an equal triangle, right? If you know the edge length, okay? So the area of this triangle, remember it's given with square root 3 over 4 a squared, right? We already find it. But this triangle consists of the 3 triangles, right? Identical. So this is also be 3 times the area of that small triangle. What is the area of that small triangle? Half of a times x, because x is given the height. Then the problem is very simple. Okay, so this side is 3 over 2ax. Okay, let's solve the equation. 3 over 2ax square root 3 over 4a squared. So I cancel a, right? When a is gone, right? And ix is going to be 2 over 3 square root 3 over 4 and a. Then after simplifying, you get square root 3 over 6 a. Then you still get the same answer, right? So you don't need to even use a Pythagorean theory, but already when we try to find the area, already get a Pythagorean, applying Pythagorean theory. All right. All right, so here's the next one I want to look at. So we have a right triangle. Okay, that's the right triangle. Now the square root of the length of the hypotenuse is of the right triangle is 2 units. So the square root of this is going to 2, right? 2 units. What is the sum of the square roots of the length of the two sides? Well, what is the sum of the squares of the two sides? Okay, so this is actually trying to test you Pythagorean theory. Okay, so understand what is the value of a squared plus b squared. Okay, well that's it. No. Right. So what is the sum of the squares of the length of the two the sides, right? If you know the square root of the length of the hypotenuse, right? So all you have to do is just write down formula, right? And since square root of c is 2, so c is going to be 4. 4 square is going to be 16. That's it. Right? So just want to don't be confused about the conditions. Okay? Yeah, because this implies c square equals 4. Okay? Okay, so c square, c is 2, c c square is going to be 4 square because c, yeah, yeah, that's right, 16. So c is going to be 2 square, it's 4, right? And then that's why c square is 4 square. Okay, that's just like that. Okay, c equals 4. Okay. Well, about the triangles, right? The triangle have a very special, important property about triangles. First important is alpha plus beta plus gamma is going to be 180 degrees. Okay. Okay. Now for the triangles, this is there's no choice. You have to if we find out a triangle in the universe, the sum of 3 angles is not going to be 180 degrees. Now what does it tell you? It's impossible. No, it's possible. If you find a triangle, triangle in the space, you measure, like 3 stars in space, right? And you can figure out draw the lines between those 3 points, and then you measure the angle at each point. You find out the angle is greater than 180 degrees. That means the universe is curved like a sphere. Okay. So that's more advanced mathematical geometry. Okay. But anyway, so we have this. Yeah, this is on the flat plane. Okay, it's very important. If it's not on flat frame, the angles are larger than 100. The sum of the angles is larger than 100 degrees, like on the sphere. Okay. So, so for the right triangle, okay, then this is alpha. This is a beta. Okay, right? Alpha plus beta is going to be 90 degrees always. Why? Because the sum of 3 angles is 100 degrees, but the one of the angles is 90 degrees, and the sum of the rest of 2 angles is 90 degrees. Okay. So now if okay, if we are told that the ratio of these 2 angles, okay, is going to be like the ratio of those 2 angles, okay, is going to be, I can give you any ratios, okay. It's like a 3 to 2, for example. Okay. Can we find alpha? Okay. How to do this type? Yeah. What is the value for alpha? Then we get alpha, I can get back, right? Now, what is the best way to solve this problem? This is the algebraic problem. Okay. Whenever you talk about ratio, I think it's better to introduce a parameter. It's a 3t. Beta is going 2t. Anyway, alpha and beta must be proportionally equal to 3t and 2t, right? Then the ratio is going to be 3 to 2. Now, if you do that, then you can solve the problem easily. So alpha plus beta is going to be 3t plus 2t, which is going to be 5t. That's supposed to be 90 degrees, right? So as long as you can figure out t, then you solve the problem. So 90 divided by 5, right? I don't have the calculator, 5, right? So it's 18, okay? So 18, t is 18 degree, then alpha is going to be 3 times 18, okay? And the 54 degree, okay? So this is how do you solve the problem. So this is not a really a geometry problem, but at least you should know the sum of those two angles is going to be 90 degrees. If you know one of the angle, then you can get the other angle. Okay. Okay, so we are speaking of triangles. Let's take a look at the next problem. Okay, what is the area? Okay, what is the area of a triangle that has side of 4, 3, and 2 units? All right, so let's draw the triangle. Let's draw the triangle. Okay, you have 4, you have 3, and the 2. Now, first of all, you have to make sure this is a triangle. Sometimes they cannot form a triangle given 3 numbers. It's impossible. Okay. So let me go over that. Why a 3 numbers become a triangle. Okay. So A and B and C are the sides of a triangle. Okay. If and only if satisfies 3 conditions. Okay. This is called a triangle inequalities. A plus B should be greater than, so A, B, and C. Okay. A plus B should be greater than C. B plus C should be greater than A. And the C plus A should be greater than B. Only meet those 3 conditions, then they indeed form a triangle. Otherwise, it cannot be triangle. Okay, and clearly the above 3 numbers 2, 3, 4 from the 3 and 4, they form the triangle. The 3 sides of triangle. Right, so it is a triangle. Okay, if I change it 2 to 1, 3, 1, 4, that cannot be the 3 sides of triangle. Okay, okay. So it's a triangle. The problem is how do you find the area? Well, for the area you have to have a height, right? You must have a height. So the area is going to be half of the base times height. Okay, but the problem you don't know the height. Okay, you don't know the height. Okay, that's a strange. It's not right a triangle. If it's right a triangle, yes. You know, if I give you the triangle like a 3, 4, 5, then you see, oh, this is the right triangle, right? But this is 2, 3, 4. It's not right triangle. Okay. For the area triangle, there are several formulas you can use. The one of the formula you have, okay, is called the Heron's formula. Okay, Heron's formula says that if you know this is 3, right? Then the area is going to be S minus A, S minus B, S minus C. And what is S? S is going to be half of the perimeter. Okay. And you say, how did he get it? Well, you can get it maybe if you have a time. It's like a research project, right? Trying to prove it. Right? First of all, you know that, right? The triangle is uniquely determined by 3 sides. Even the shape of the triangle is already uniquely determined by the 3 sides. So the area definitely is completely determined. Then depends on 3 sides. So question, how does it depend on 3 sides, right? Are you able to get it? All you have to do is to find the height. It's not easy to find height, okay, right? But let's use this formula to solve the problem first. Then you have to trust this formula, right? So if we have 2, 3, 4, right? Then S is going to be half of 2 plus, right? So that is going to be actually is going to be 9 over 2. Okay, good. Then the area is going to be S 9 over 2. 9 over 2 minus 2. 9 over 2 minus 3. 9 over 2 minus 4. Now let's simplify each of them. 9 over 2 minus 2 is 9 minus 4 is 5. I think that's 3. And that's, I think it's 1. Okay. So you look at this. Okay. Clearly, you will get 3 over 4. I think 5 times 3 is 15. I cannot change it. Okay. So it's get very strange numbers. That's a formula. Okay. Now, if you have formula, okay, and how many, yeah, this is H, right? And I can put here, assuming this is the triangle in this form. I'm not talking about the triangle looks like that. Sorry. If the triangle looks like that, I will consider this H instead of that H. Otherwise, it's all side of the H, right? That's always can do that. So how many? You see, actually get 2 right triangles here, right? First of all, x plus y equals c. That's the first equation. You have a, b, c are fixed, but the x, y, h I don't know. So another equation is x squared plus h squared equals a squared. Then here's a y squared plus h squared equals b squared. All right. My question is, can we, find h and express it in terms of a, b, c? Now, if you are able to express h in terms of a, b, c, then you get the area formula, right? Then the area formula is gonna be half of c base times h, right? Got it? So technically, you can do it by yourself. Look at those 3 questions. That's a research project. Okay, you can do it. So you give us 3 sides of a triangle. If you don't have any formula, are you able to find the area? I would like to do it in this way. I draw the line against which right triangles, but this is it's beyond the basic math class. Okay, I'm not going to continue. I just tell you, you have 3 unknowns, 3 given numbers a, b, c, and trying to find the h. You can at the same time you can find x. Okay. All right. So let's move on to the next problem. So this is an advanced math class problem. Okay. I'm not going to talk about it right now. Okay. Just tell you, get some ideas. Yeah. Okay. So what is next problem I want to talk about? All right, my next problem is from homework. Okay, I have a, let me draw the picture here. It's a little bit strange. Okay, so this from here to here, it's y. And this is x. What does it mean, x? Okay. So this figure shows a square of a side y units divided into the square of side x units and 4 congruent rectangles. What is the perimeter in the units of one of the 4 congruent rectangles? So we are going to find out. Yeah, we're going to find out the perimeter of this. Okay. Now, actually, you can even find out. Yeah, to find out this, right? So let's code A. Let's code B, and you needed to figure out A plus B. Okay. Now there are many ways to solve this problem. Let's find all possible relationships. All right. So what is the area? Let's find out the area of this. Okay. What is the area? Yeah. First question. What is the area of the rectangle? Okay. Let's do this first. Okay. Well, this is simple because the area of the rectangle. Okay. You look at the difference. X squared plus y squared. X squared plus y, x squared minus y squared, right, is going to be the area of all the 4 rectangles. So if it's divided by 4, that gives the answer, right? So you get the area. But you don't know the, so this side, yeah. Then you see that, right? Let's see. So this is going to be B, right? And that is going to be A, right? All right. So what is the X? X is going to be B minus A. Okay. X is B minus A. Okay. Now what is the Y? Yeah, the second question. Okay. Find the parameter. Okay. Okay. Now what is X, right? X is the difference of these 2 edges. Okay. Right? And what is Y? Y is going to be the sum of those 2 edges. Because this from here to here is A. So total length is A. Okay. Okay. So I want to not only find the perimeter, I want to find the dimension of the rectangle. Right? So the perimeter is already know that because A plus B multiplied by 2 is give the perimeter of this. Okay. I want to find the dimension of the rectangle. So you can find the dimension of the rectangle. Okay. Right? Let me put it here, put it this A times B. Okay, so A times B is gonna be y squared minus. So let's look at this. Okay. So you can actually solve for X and solve for A and B. You add them together, 2B is gonna be half, 2B is gonna be X plus Y. So B is going to be half of X plus Y. All right. Then you get A. You can do subtraction. This equation 1, equation 2. Equation 2 minus equation 1. 2A is going to be Y squared minus X squared. Y minus X, sorry. Y minus X. So A is going to be Y minus X divided by 2. So you got not only that get a perimeter, you actually get the dimension of this rectangle. Okay. So finally you get A is going to be half of Y minus X. B is going to be half of Y plus X. Okay. Of course, this also implies A times B, which is the area, is going to be half of Y minus X and times half of Y plus X. You end up with the same answer we got at the very beginning. Okay, so Y squared minus X squared divided by 4. Okay, so those are the geometric problems from the homework as I did quick review. I would like to talk about something else today. It's also geometry, okay? Remember for polygon, okay? Remember for the polygon, more than the than triangle. So if we have angles, okay, so remember that the sum of all interior angles is going to be n minus 2 times 180 degrees. Okay, so that means alpha 1 plus alpha 2 all the way to n is going to be n minus 2 times 100 degrees. Now there's another formula shows that if you rotate in this way, this is called the exterior angle, beta 1, beta 2, beta 4. Okay. Yeah, the orientation is very important. Okay. Then this angle is called exterior angle. The sum of exterior angle is always equal to 360 degrees. Okay. It's never changed. It's independent how many edges that do you have. Okay. So that means beta 1 plus beta 2 all the way to beta n is going to be 360 degrees. It's interesting, right? So if you actually, what happens that if we increase the edges, increase the size of the polygon, you decrease the exterior angles because they get more and more narrow, right? Right. So here's a question: what is the exterior angle of a what is the exterior angle of a regular 9-sided polygon? Okay, so that's one of the questions I saw before. All right, so exterior angle. Okay, I just want to find one of them, not the sum. Okay, remember this. Okay, the 9. Yeah, this is a. Okay, this is a beta. They're all equal, right? I cannot draw the 9-sided polygon. So the sum of this is beta. 9 beta, but this is going to be 360 degrees. Okay, so beta is just this divided by 9. It is 40 degrees. Okay. All right, my next question is, I see the picture here. Okay, this is this side is a rectangle. This side is a square. I have to draw the square clearly. It's in better. Okay. So what we're given here is the perimeter of the rectangle is 40. What is the ratio of the area of the square to the area of the rectangle? Okay. We also given, we also given this side is 6. Okay, make it easy. Okay. So I know the perimeter of the rectangle is going to be 40. Okay, I want to find out the ratio of the areas. Okay, well, the area of the rectangle to the the area of the square to the area of the rectangle. Rectangle. Okay. So you said 36 to 84. Okay. Well, let's see. This is W. This is L. This is L. So this is W, W, W. Okay. So you know that W is going to be 6. Okay, the square. So the perimeter of this will be, right, 2L plus 2W is going to be 40. So 2L is going to be 40 minus 2W, 12, right? So that is going to be 28, okay? So it's 28, so L is going to be 14. So once you know that, then the ratio is going to be the area of the square, 6 square. Then the area of the rectangle is going to be 14 times 6. So it's 6 over 14, right? So it's a 3 over 7. Haha. It's 3 over 7. Right? This is pretty straightforward. It's not a, it's not a secret. Okay. Well, our next problem is going to be, I hope you remember this, right? And I have 3 sides and 3 points. Here's -3, -1. And here's another point, B, 2 and -3. And that is a C, 1 and 2. I connect those 3 points And what is the area of triangle? ABC. What? Okay. So find the area of this triangle. Yeah, the idea is to draw the square. Okay. You cannot, if you just focus on this triangle, you are not able to find the area. First of all, you don't know the edge length. You have to take much more time to figure out the edge length. Then use the Heron's formula. That takes forever. Okay. So what they do is you put it into the square. Okay. Okay. You will get a fraction. You're not going to get a square root of some numbers. Okay. So let's figure out the length of each triangle. Okay, so you have 3 triangles on the side. Okay, that is the idea, right? And each of the triangles is the right triangles. So if you're able to find the area of this rectangle, it's not necessary to be square here. And then subtract the area of the 3 right triangles, then you get the area of the triangle in the middle. So let's figure out each side. From -3 to 2, that's a 5. From 1 to 2, that's a 1. Okay, from -3 to 2 is here 5. So I think from -3 to 1, it's a 4 here. And this is this 3, that's a 2. Okay. So actually this is a square. So area of the square is a 5 square. Then you subtract the area of each triangle, the one on the bottom, the one on the right hand side, the one up left. Okay. Okay. So you will get 25 minus 5 minus 5 over 2 minus 6. Okay. 25 minus 5, 20 minus 6 is 14. 14 minus 5 over 2. And actually it's going to be 14 minus 2, right? The 14 minus 5 over 2. Okay. So 28 minus 5, 23. Okay, so this is answer 23 over 2. You probably get 7, it's 11.5. So use the subtraction method, you can find the area of triangle. Okay. Now, if you want to find each edge length, you will get, for example, A. It's a square root of 2 square plus 5 square, 25 plus 4, 29. It's a very bad number, right? And the other one is a square 1 square plus 5 square. It's 26. Then 3 and 4 is okay. C is going to be square root of 3 square plus 4 square equals 5. So you get you get a very strange triangle, right? If you, of course, you can use the 3 sides to find the area, but it's very difficult to simplify it to this fraction. Okay? Yeah, it's not easy. You will get very strange numbers if you want to use Heron's formula. Okay? You can, technically you can. You can say, look at that. S is going to be half of A plus B plus C. And what do you get? What you get is going to square 29 plus square 26 plus 5. Whoa, right? Then this have to put inside the radical. And how do you get rid of the radicals inside radicals? That is the question. Okay, so it's not easy to use. It's not easy to use Heron's formula to get a simplified answer, not a complicated answer. All right, we stop here, and you are going to get another set of homework.